Hey everyone, I hope you are doing excellent. So, if you don't already know me, I'm Saki. I'm a mentor with Hack Your Future, and I'm a freelance web developer. And I'm here today to teach you a little bit about databases and more particularly about database migrations. Um, so, let's first dive a little bit into the problem that we are trying to deal with here. So, imagine that you're working on your own on a project. You have some code that you're maybe putting in GitHub, maybe you're just keeping it on your local computer, and you have a database installed. And whenever you need to set up some new data in your database, you will go in your database and you will create a table for that data and you will create some columns and stuff like that. You might be using, I don't know, like MySQL Workbench maybe to create those tables and to create the fields and all that stuff. Um, and then whenever you create a table in there, or maybe you rename a column or something like that, you have to make corresponding changes in your code, right? So imagine taking the same situation and scaling that up. Once we have multiple people working on the same project, on the same code, on the same database, these people developing, they will have copies of the database local on their computer. And that's where we start to get problems. So I made a little bit of a diagram here. So we have Alex is one developer and Diana is another developer. And Alex is mostly working on the web application, on the front end and stuff like that. Diana is mostly working on the back end. She's working on the database quite a lot. Um, and usually when Diana needs to just create a new table or something like that, she would just go into MySQL Workbench and she would create that table on her local computer. And when the product manager comes and tells them, oh, now we need all the code on production, Diana will just like connect to the production server, and then she will go to connect her MySQL Workbench to the production server, and she will make all of the corresponding changes on the production server. That's how she's been doing it for years. But Alex is maybe not that happy with that approach because the problem is every time he get in the morning, he checks it out some new code, and probably when Diana she's like changing stuff in the database, she's also changing some stuff on the back end where there's some variables, there's suddenly changing names and stuff like that. But whenever Alex checks out the new code, he gets those variable name changes, but he does not get the changes to the actual database. So whenever he comes in, he experiences that his application is breaking, it cannot run, loads of problem. And he hasn't touched anything. The only thing he did was he's just pulling the latest changes from GitHub. So he starts getting really frustrated with this. So we need some sort of way that we can solve this. And the way we can solve this is with migrations. So what is migrations, you may ask? So given this is Hack Your Future, some of you might have a lot of experience with migration, probably with human migration, people moving from one country to another country or one place to another place, right? But migration can apply to a lot of other things. You can see here the Wikipedia page that you can apply to a lot of stuff in natural sciences and, well, arts and media down here, but we also have a section here about information technology. So here, migration could, for instance, be content migration. So it could be taking your content from one website, moving into the new and shiny website that's the next company built. It could also be something like schema migration that we have down here. Whoops, I didn't plan to do that. Schema migration, so that's the management of incremental reversible changes to relational database schemas. That might sound a little bit intimidating right now, but that is actually the topic that we're going to dive into today. So we have incremental changes. So imagine we're developing, we keep developing something new, we make changes every single day, right? We want to make sure that we have reversible changes. So imagine that we deploy to production, but then we realize, oh my God, it doesn't work. We made a huge mistake. We need to go back. We need to go back to what we had before. And everyone's just like, can you just run the backup? And you have like, yeah, maybe you don't actually have like that backup of the database because new users were signing up on the day after you rolled out uh, the new version. So if you apply the database, then you will delete those users, and they won't be very happy that they were deleted from your website, right? So just running a backup might not be an option. And yeah, reversible changes, and then they say that it applies to relational database schemas. And we are working with a relational database when we're working with MySQL. So this is where we're going to be working with. I haven't actually tried pricing schema migration, but I guess you can read a lot on Wikipedia about database migrations as well. But I suggest that you start out going to your README file for your final project. You can see this project here is just called boilerplate for FP final project. That's like the repository that we use to create new final projects. I'm making this video with the idea that it should be reused for future final projects as well. So instead of going to the boilerplate for final project, you should of course just go to your specific final project. The structure of the project should look like this. So if you go down here, you can see like the table of contents. And you can see there's a section here called working with Knex and migrations. And if you go to that section, you will get into this file here. Okay. So we established that migrations are about getting from one place to another. In the case of database migrations, it's about coming from one state to another, one functional state of the database to another functional state of the database. And the gist of it is that we will write some scripts, and these scripts will apply changes to your database. And rather than trying to put a database into GitHub, which cannot actually really be done, it can be done with some databases, but not with a MySQL database. Rather than trying to put the database itself into Git, we just put those scripts that make the changes to the database into Git. So that way we will have a history, we will have version control on our database. So here in the README file, I made some migrations in pseudocode. So it's not actually, you cannot just type this and have your computer do stuff. It's pseudocode. It's just a language that I imagined up for this purpose because I think this is simpler to read than some of the real migrations that we're going to be writing later on. So we have this concept of having up migrations and down migrations. And up migration is taking you from the current state that you have to the future state that you want to have. A down migration is taking you from the future state to the current state. And the idea about the down migration is, of course, that situation where you deployed something on production and then you realize it didn't work. We need to go back, but we cannot just use the backup. Right. So let's just walk through these migrations here. So the first one is an example of an up migration, right? The first thing we do is we create a table of products. And inside that table of products, we will add some columns. We have one column called name and one column price. And they have the data type string and decimal, respectively. What is the reverse action of creating a table? Because imagine the down migration, that always have to be the reverse action of the up migration. So what is the reverse of creating a table? It is to destroy, delete a table, drop a table, like we say in MySQL, right? So we just drop the table products. We don't need to go in and explicitly drop the columns on that table because this stuff up here, creating a table, that happened in one go. That was just like one action, creating a table with columns. So this is deleting a table with all of its columns. So another example here is renaming a column. So here, rather than creating a table, we select the table. And then on that table, we apply an action. So the action that we apply is rename. And what we will rename is we'll rename name to product name. What is the reverse of renaming name to product name? Reverse of that is to select the same table again, perform a rename action, and then rename product name to name. In some cases where you have like real data in your database, you have your site launched to production, which will generally not be the case when you're working on the final project. But if you have it launched to production and you actually have some users who might be signing up in between you running these migrations, you might actually have to think about like moving data around. So taking data, so if you, let's imagine that you, first time you design your database with a user has a column called name, but that's just the first name and the last name in one column. And then later on you decide you actually want to have those split out into two different columns. How can you do that? You can write a migration where you remove the name column, then you add a first name and you add a last name column. But then you have to have some logic in there along with your migration script that would like to take all of those names, which is first and last name, and then split it by spaces or whatever, how you figure out what is the last name and first name, right? And that script has to be putting the data into the first and last name. So scripts like that, migration scripts like that have to go together with your migration file. But I think it's generally out of scope of the final project that we're doing, because this will only be relevant once you are in production, once you have your site launched. That will be really relevant. Up until that point of time, we are still in control of the data we are putting in. So if we need to make some big transforms to that data, we can just like make it to the data that the seed data we are putting into the site. And I'm going to be talking more about seed data later on. So as I told you, these migrations up here are in pseudocode, so you cannot actually type this in, expect it to work. What we are going to be working with is something called knexjs. And Knex is a library that can do a bunch of stuff, and it's based on Node.js, of course. And it can help you whenever you write an application in Node.js. It's really helpful for managing how to get connection to the database. It can help you to run migrations and seed files. And it gives you an API, command line interface API, that will help you create the migration files. And later on, we'll also look into how to create seed files. And yeah, it can run those files as well, and can do some other things with that. And then it has like an API to actually build SQL queries. So when we're working with Knex, normally we don't actually write SQL. So all the stuff that you learned in the database class about learning SQL, you can more or less throw that out the window. That's not quite true, because all of the same concepts still apply. You just need to write SQL by writing JavaScript, and we'll look more into that. And you will need to know the underlying SQL somewhat in order to understand how to manipulate the JavaScript. But doing something like this is quite common. You would probably, once you get out into a real job, you will probably run into something like Knex, which is a query builder. So that's just like a JavaScript API that can build queries. Or maybe you will run into something like a full-fledged ORM object relational mapper, and an object relational mapper is very much the same as Knex, but it will do more stuff. It will have more tools in terms of like the migrations part and seeding and all that kind of stuff. And it just like, but it solves the same problem. So the problem that we want to solve is we want to have some formal way of writing scripts that will be applied to our database, and those scripts should be able to be put in GitHub so we can version them together with the rest of our code. So, as I told, Knex can help you set up the database. So you can take a quick look at the Knex file. So this Knex file is a configuration file, and Knex expects this configuration file to be present whenever you go into a folder and try to run Knex. It expects to see the Knex file in the same folder. We made a little utility where you don't need to think so much about that. But whenever Knex is running, it will try to find this file, and then it will look through the configuration you have set here. So you can see here we have currently set it up to run with the MySQL 2 client, and we have some details about the connection. We tell it what is the host, so that's the location, the IP number or local host or whatever. the port, the user, the password for that user, and the name of the database. So you can see that we don't actually have like something like password root, user root, or host, local host, or something like that written here. Instead, we have something called process.env, and then we have something here, right? So what is process.env? Process.env is the way that you read environment variables in Node.js. Environment variables is something, I'm not sure if you have met those before this project, but they are really important when you start to try to make a real website and you want to get it out in the world. Because if we were to put in our database password right here, this file that we're looking at here, that one goes on GitHub. And it's actually an open source project, so everyone will be able to see that password. Everyone would be able to go straight into our database and read our data, modify our data, do malicious things with our site. So to avoid that, we use environment variables. Environment variables are set on the specific environment, so that means on your computer, in the case of making a local development environment, it would mean on the production server if we put it out on a production server and put it open on the web, right? And so on. So that means it's internal to the server. You need to have like physical access or SSH access or something like that to the server to actually be able to ever see that password if it's set in a environment variable. So environment variables is the safe way to put secret data into your project. And we are using a package that's called .env. We including it up here. And that's just an easy way to set environment variables. Remember, we cannot put the environment variables into GitHub, so we don't actually have a .env file on our GitHub, but we have something that resembles it very much. We have a .env example file. So this is just examples of what you could put into your env file. There's none of this stuff in here that's actually secret. This is just default values for your development environment. And if you want to have your development environment have a more secure password than root, you can change that in your MySQL and you can go into your actual env file, because you're supposed to, right next to this .env example, you're supposed to create your own env file. Let me just show you an example, but actually I did some stuff before. Let me just close all of this stuff and check out master. So now we're back to master. So my project here, I have the .env example file that we just looked at on GitHub, and I copied that file over and called it .env. And in my case, on my computer, I have a very secret name for my database. It's called boilerplate DB rather than final project DB here. But the rest of it, I just left the same. I'm just running with root on my database, and yeah, it's my local computer, so I'm not worried about that. But if it was like a production environment, you should definitely not use the root user, and you should use a secure password. And once you do that, you just like upload those things in the env file and make sure it matches whatever you have on your MySQL server. So that was just a little bit of a detour to the .env file, but you can read more about that in the README file here. I think here is some stuff about env files. I think there's some more stuff as well. Anyway, it's a little bit of a detour from the database migrations. The main thing I wanted you to see is I wanted you to see that Knex file here, which is the configuration file for Knex. And you can see it has like, again, it has the connection data here, and then it has like a directory where it's supposed to look for seed files. And we're going to be talking about seed files more later. The main difference between development and production is that production has a different directory for seed files. We don't want the same testing data on production. We may not want any testing data on production actually. But maybe we do want to have like a few things set up on production that we don't have to go in and do manually. So we have that option by having this folder here. Cool. So that's the configuration of Knex. If we go back to this file here. So Knex also provides a folder for our migrations. And the way Knex works is it will go to that folder and then it will scan that folder and it will look for any migrations that have not been applied to the database yet. If it sees a migration file in there that it already knows, has been applied to the database, it will not run it. So in general, everything you write in migrations is only going to get run once. And let me just, I'm just gonna wipe everything I have in my database. So right now, if you go and have a look in the server migrations folder, oops, it was already open. You can see that our final project comes with one migration to start with. It's called create modules. Create modules probably does not have anything to do with the final project that you're doing. It's just an example. It's from an old final project where we are doing like Hacky Future modules, like classes, right? And it's just an example to show you how to write a migration. So if we have a look at this file here, you can see we are exporting a up function and we are exporting a down function. And each of these functions, they return something. And to get whatever it is we're returning, we have to call something with knex.schema. You can see that goes down here again, but we have something different going on here and here, right? So the up migration is the migration that takes you from the current state to the future desired state, the place that we want to go to, right? You can kind of imagine if it's like travel itinerary, it's like, then you have to take this train, then you take the plane, then you take a taxi, then you can take a train again, something like that. And then you're at your destination, right? And the down migration is the reverse. So that is, you have to take first the train, then the taxi, then the airplane, then the train, something like that, right? The same in reverse order, probably. But maybe on the down migration, the route back, you could need to do something else. Maybe you need to take 2 taxis or something like that. But the main thing is you need to get to the exact same state where you started. The start and the end cannot be different. So in this case, what's happening is we're creating a table. The table is called modules. The first thing we do here is we create a ID for table. So that function here, table.increments, that will actually create a column called ID. It will set it to auto increment. Probably not null. It'll do a few other things. So yeah, primary key. It will set it to be the primary key of the table as well. So that's just like shorthand for you could do this as well with these calls down here. You just like have to use 3, 4, 5 of them. Here, table.string, that will create a column with the type string and the name title. And in this case, it's set to be not nullable. All of this will translate into SQL. We are creating another column with the type datetime, and we're calling the name of the column is called start date. Again, not nullable. Here we have another datetime. It has a default value, so it's filled out with a value when we create it. And we pass in the function that's called knex.fn.now. So that will just take the time right now and then fill it into the created at. And in case it's updated, it will, I guess it's created and updated at the same time. So we're doing the same with the updated at. And deleted at, we're not filling that out because that's only something we fill out if we actually delete the data. So what is the reverse action of creating a table modules with all of these columns on it? The reverse action of creating a table will always be to drop a table. It doesn't matter how many columns you added to that table. All of this takes place in one action. So this is like the reverse of having created that table. Yeah, so this is an example of a migration. Let's have a look at how we actually run our migrations. So if we go back to the README file, here we have a little table with some commands that we can run. Up here, I explained there's like few different ways that you can run these commands. I think there's a little bit of a mistake in this table here. I think I'll fix that later, but you have to type npm run before what you see here. Because this Knex here is not actually like directly referencing the Knex library. If we make a little bit of a deep dive into our package.json file, you can see that we have a command called Knex. That's the command that you run with npm run something. Npm run something will always call stuff that we have here in the scripts. And stuff here in the scripts, if we call something like Knex, it will call the stuff that we have in node modules. And we do have Knex in node modules because we have it as a dependency somewhere here. There we have Knex. So by running this command npm run Knex, we're actually running the local version of Knex, the version that is inside this project. Quite often when you're using Knex, you might install Knex globally. The problem with installing Knex globally is that you may forget to update that Knex, and maybe you need to use one version of Knex for one project and another version of Knex for another project, and then you have trouble. Another option you can do is you can just run npx Knex, and that will run Knex without actually installing it. It will just fetch it from online and take whatever is the latest version of Knex and use that to run commands. And again, you're not sure that you're running the same version as was intended for this project. So by doing this down here with npm run in front of it, you make sure that you run the version of Knex that is designed for this project. Okay, that was a little bit of a detour in terms of like how to just call the Knex command, but this table here contains the main commands that you need to be using when you're working with Knex. The one that is probably most common use is Knex migrate latest. So what Knex migrate latest will do is it will have a look at your migration folder. Where do we have that? We have it here, and then we'll have a look at the files in here, and we'll compare the files in your migration folder with the files that Knex knows it already has executed. In this case, we're running a completely fresh database. Nothing has executed in the past. And there's only one file in here. So Knex migrate latest will only run that one file. If we had two files in there, it would run both files because none of them were executed in the past. As an alternative to Knex migrate latest, we also have Knex migrate up, and that will only apply one migration from wherever we are. So in the current case, the result will be the same if we run Knex migrate up or we can run Knex migrate latest. But we can probably cover that a little more detail later. So npm run Knex and then the two dashes here. You can see those two dashes are not in the Knex documentation. You need to figure that out yourself. That's because we wrote that little script here to use the local Knex. So if you look at the Knex documentation, let's just find that. I already have it open, but there's a link here. Just open it like that, and then maybe close the old one I had over there. So this is a Knex documentation. So whenever you see them, if you go to the CLI, command line interface, down here, migrations, here they tell you to do something like Knex migrate make migration name. In this case, you need to do Knex -- space migrate make migration name. That would be equivalent. That just makes sure that you're running the local Knex. Let's have a look here again. So anyhow, we need to run Knex migrate latest. I think I typed it out almost. Knex migrate latest, and it tells us that it did run one migration. And you can actually see that this is showing us all of the SQL that it's executing on the database. And the reason that it's showing us the SQL that it's running on the database is actually because inside of my .env file, I have this one turned on, debug Knex query. That's something that can be pretty nice to have running on your local environment. But if you feel like it's just making too much noise having all of this SQL coming out, you can do like this, and we won't see it. This is how it is by default. If you go and look into the default here, you can see it's turned off by default. I had it turned on now. Let's just try to keep it off and then we can turn it on later. Cool. So I just ran one migration. Let's have a look at our database. So before our database was completely empty. Now we have a modules table in here. And if we look at the structure, you can see it has an ID. It's an unsigned integer. It's not nullable. It's auto increment. All of this just came out of doing that. Remember that like table dot increments, and the table is modules. It's referenced up here, right? So it knows just to create an ID table on modules. Then it has a title, which is a varchar or a string if you want. Start date, end date, class, created, updated, and so forth. But there's more in here in the database. You can see there's actually something here called Knex migrations. And I don't care so much about the structure here. I want to see the contents of that table. So you can see there's actually something familiar here. That's the name of the migration that we had in our folder in here, right? So what Knex does is that it registers that I did run this migration. This is the time when I ran it. This is the name of the migration. So this is the way Knex keeps track of what it did run in the past. If I rename this stuff in here, Knex will actually run it again, and will probably break because it's not designed for, you cannot create the same table twice in MySQL. It's going to complain about that. Cool. So we have our up migration here, and if you remember the down migration, it will do the reverse action. So if you want to try to run the down migration, we can either do rollback. So rollback, just roll back one migration. And if we go into our database, you can see now the modules table is gone. We still have the Knex tables in here, but now actually the Knex table here is empty because nothing has run at this current state in time. Rollback will roll all of the migrations you rolled on with migrate latest. But you also have a migrate down. So let me just show you. So I told you that you could either run up or you can run migrate latest. If I run migrate up, again, we have the modules table. We have all of the columns here. So here the result is exactly the same as when we ran migrate latest. It's just because we only have one migration. If we had more migrations, up will only take the first one of the series of migrations. And equivalently down will take the last migration that we ran and roll that back. Whereas latest will roll back everything we did in the last go. So if we did use migrate latest, down will, sorry, if we do use migrate latest, then rollback will take everything from migrate latest and take it back down. Cool. Aside from now, we covered migrate latest, we covered rollback, we covered up, we covered down. Now we have something here called Knex migrate make, and that is going to make a migration because now we actually want to try to make changes to our database schema. So how may we do that? So I would like to try to, let's try to add a string. Oh, that's not where we want to go yet, at least. Let's try to add another string that's called difficulty. So as I told you, these are JavaScript modules that we're teaching at Hack Your Future. Some of them are more difficult than others. To start with, we just have an implementation where you have like a string where it can say high, medium, low. So let's just try to add that string to the table that we have here. So what I will do is I will again have a look at the documentation here. Knex migrate make migration name. So the migration name, I'm supposed to fill that out. That's me giving it a name. So I'll delete migration name and then I give it a name. So add difficulty column. Oh, I forgot. npm run first. Cool. So here we have a brand new migration template. There's nothing happening in here except we have two empty functions. We have up and we have down, and now we need to fill those out. So to fill them out, we can do, so we're not creating a table anymore, we are modifying an existing table, right? So how might we do that? If you go to the Knex documentation, I'm looking for probably under schema building. I think I'm looking for table. No, I'm actually looking to select the table up here, schema builder. So it's called knex.schema.table, and then the name of the table, and then a callback. And here's an example. So they have an example here where they take, this is actually the same example that I had early on with a user. So they used to have a full username, and then they drop that column, and then they add in a first name and a last name instead. So let's just take that as an example. And did they show? I didn't show a down migration. We'll figure that out. So we are going to select the table modules. That's where we are making our changes, right? And we are not going to drop a column at the moment. We're going to add a column, and it has the type string, and it will be difficulty. And then we remove that line there. The reason I just commented that one out is because I actually need it for the down migration, right? Because whenever I create a column, then the reverse action must be to drop a column. So maybe just copy difficulty, and then we can go and put it, whoops, in there, and comment it back in. Clean up. So, currently we have one migration that ran, right? I just saved a second migration file here. So my expectation when I run knex migrate latest, or maybe knex migrate up, that doesn't matter. My expectation is that this migration will run. Knex migrate latest. Cool. So it tells us that it ran one migration out of a total of 2. As you can see now, we have 2 migrations that have been executed. Modules. I expected it to have a difficulty field. I see now that there's no difficulty field in here. Let's have a look. Oh, it's telling me something here, that my migration did not return a promise. So Knex is based on promises, and whenever you execute something on the database, it's asynchronous. You never know how long it takes for your database server to respond. So this function here actually returns a promise, but I have to pass that promise up to the up function, so I have to return it. So I just forgot about that. Given that this is a case, I know that nothing was executed in here and nothing was executed in here, so my database is still in a consistent, no, it's actually not in a consistent state anymore, because if we have a look in here in data, here it looks like I already did run 2 migrations, but effectively this second migration here was empty because nothing was working inside that migration because I forgot to return my values. So Knex thinks that it ran 2 migrations. In reality, it did not. The database never saw the changes from the second one. So the problem now is if I try to run my latest migrations, it's going to tell me everything is up to date, I'm happy, everything is fine. But the reason it's saying that is because the 2 files here, it thinks that it did run both of them, but the second one never ran. And if I go and look in my database, I still won't see a difficulty field here. So what I recommend doing is when you're developing migrations, in between when you're trying out stuff and you're like, oh, it didn't work, how do I? Don't just run your migration again. That's not going to work. You could go in and kind of like hack it a little bit. So you can go in here in data, and then you could just like remove the second guy here, and then it would run that stuff. But who knows? Maybe you messed up the order or something like that. So the safest way to test your migration is always delete your entire database. It sounds really radical, but delete your database. I'm just going to select the tables here, delete them, and save that. And then just run npm. Oh, let's have it on my. Maybe that's not actually faster. Npm run knex migrate latest. So now we just run all migrations, and you can see all migrations in this case is 2 migrations. Yeah, so it ran 2 migrations. I think batch 1 was not actually how many migrations run. It's just, I don't know, the batch. I don't know why the batch is in this case. But it did run 2 migrations. 1 migration, 2 migration, modules, structure. Now we have a difficulty field, and it has the type varchar. That's a string, right? Cool. So we actually just wrote our first up migration. Now we need to make sure that the down migration is working as well. So we can either run migrate down to just go 1 back, or we can run migrate rollback to roll back everything. Let's try that. It did roll back. Actually, in this case, I want to see just the 1 migration being rolled back to make sure that down. So if I run the down migration, I should have modules. I do. And it should be without difficulty. I don't see difficulty in here. That's because we're just about to apply the difficulty migration. So we can run migrate up to get 1 up. And if we refresh, we have difficulty in there. Beautiful. So we just wrote our first migration, and we have the up migration and the down migration running successfully. So let's imagine that we want to take it 1 step further. So now our product manager is coming to us, and he says, yeah, it's really nice that you can see like it's high, medium, low difficulty, but could we have like a description telling why it's high, why it's medium, and so on? And you're like, yeah, sure, we could do that, but we probably best if we take it out into a separate table, right? So let's have a look into how we can write a table where we're going to store all of the difficulties along with their respective descriptions. So that's going to be a new migration. So even though we just made a migration where we added the difficulty field here, we're not just going to delete that difficulty field because we changed our mind. We're going to leave it in there. You can never edit old migration files. At the moment that you put a migration file on GitHub and shared it with others, you cannot edit it. If you have it locally, you can edit it, but as I just told you, you should wipe your database entirely between each run, because if a migration has been run and part of it was working and then part of it was not, and then you change it and stuff like that, then you can get in an inconsistent state, and then you're expecting your database to work in one way. So the next migration you write might be completely wrong because you just happen to have your database set up in a strange way. So that's the best way to avoid having like errors following on errors. I don't know what the correct word is for that. Cool. So we want to make a new migration on top of. So yeah, we're not changing old migrations. So we always make new changes by applying new migrations, right? So we want to make a new one here. Migrate make add difficulty table. So now we are turning difficulty into a table instead of having just a column on modules. So we get a new empty migration in here. So we better return our promise this time. Knex schema. And what are we actually going to do? We want to create a table. Create table. The name of the table is going to be difficulty. And we're going to make a function that we feed into there, a callback function. I could do like a just type function, but I prefer to use arrow functions. So let's do that. Table And now we can do stuff with table in here. And when we do stuff with table there, it will be turned into SQL. So, how was table.increments? I think that was the one to get an ID. Table.increments, we can use that. Maybe I think we can use a bit of this stuff here. That's actually a good tip. If you want to build something, there's a really high likelihood that someone else already did a migration for it in the past, so go and look in the old migrations and steal stuff from there. Just make sure to update all of the names. So I want my difficulty to have two strings. I want to have a label string and a description string. So label goes here. You cannot leave that empty. And I want to have a description. Oh, no. String still. Description. Should we be able to null that? No, let's keep it non-nullable as well. Kind of like having all of this stuff down here. We created that, updated that, and deleted that. So let's just steal that. Cool. Again, what's the reverse of creating a table? That must be to delete the table. Knex schema dot create. Oh, drop table. Difficulty. Let's just have a quick look at the Knex documentation and see if there is actually something called drop table. There is something called drop table, and it turns out I think I was pretty much bang on with my syntax. Knex schema drop table difficulty. Cool. Of course, you're not going to remember all of these things like in the first couple of attempts, but once you've written a few migrations, it's not too hard to do it. Yeah. What do you say? I feel like I'm pretty confident this is the reverse of doing that. I'm not sure I got all of this right, but let's run the migration and test. Migrate up. It did run the migration. That's beautiful. So now we have a new table here, difficulty. It has an ID, looks good. Label, looks good. Description, created out, updated it, deleted it. Very nice, looks good. Down. And it removed the table again. That's awesome. So I'm not sure. I actually want to. Now I need to add a foreign key reference as well. Not sure if I can do that in the same migration. Let's just make a new migration. Migrate, make set difficulty foreign reference. So what I'm doing now is currently the modules field have difficulty as a string still. We do have a new table for putting those things in, but we still have it as a string on modules. Instead of having it as a string on modules, we wanted to have it as an ID field that's referencing the corresponding difficulty table. So we have a new migration now. And we need to do, we need to remember to return Knex schema dot. So we are not creating a new table, we are modifying an existing table, so we want to use this one. We are doing it to the modules table. Yes, like that. Table dot. So we need to delete the difficulty column. Drop column difficulty. And then we need to create a new column. it's a um, it's just an ID column thing. Let me just I have somewhere in my notes here. Yeah, so I think we need to manually make like an integer first, and then we need to set that integer to be a reference, a foreign key reference. So let's just quickly dive into the Knex documentation. Integer table.integer, and then the name of the integer. And now it's going to be called, we are on the modules table, right? But we want to call it difficulty ID. And I probably want to have it unsigned since it's an ID. I don't necessarily think it is not null, because I think you can maybe have a module without having a difficulty on that module. If we want to make sure we always have a difficulty on the module, then we make sure to make it not null. And yeah, we can actually change that here. I mean, let's do it. Not nullable. That's what it looks like, right? Not nullable. That's what it looks like. So that's the ID right there. But right now, MySQL does not know that this is a foreign key reference, so we need to do table.foreign. Then we tell it that, maybe find the documentation again. So you can see here they're creating our integer. They're doing essentially the same that we are doing right now. Table.foreign, then the name of the column that we want to be the foreign key, and then we're telling it's referencing then the name of the table and then the name of the column in that table that we're referencing. So let me just copy that over here. That's annoying. Table foreign user ID. Now it's difficulty ID references, and we want to reference the table difficulty. I did not uppercase it. Dot, and it should just be called ID because we used the. Oh, I haven't actually run the migration, but it should just be called ID because I used the increments here. That would just default to giving it the name ID. I think you can pass in a different name if you want it to be called something else than ID. Difficulty.id. All right. So that should create that foreign key reference. Then on the down migration, it should complain if I just try to delete the difficulty ID. Yeah, okay, let's just think about it back again. So what we need to do on the down migration is we need to remove this guy, and then we need to add back in the regular string integer. So we can go back in time. Turn, I can just select that line, copy it. So we want to, I mean, let's just try to delete the table dot drop column. But I think we will have Knex complaining that we are deleting a column that has a foreign key reference. So we need to delete the foreign key reference on its own. Table dot string. So here we just create the string one back again. Let's see if it works. It did actually work without complaining. That's interesting. No, we didn't run the down migration yet. So the up migration is working so far. Difficulty has been created. We have ID, label, description, blah, blah, blah. I think we saw that before. Now under modules. Oh, did I run up or did I run latest? I just ran up. So I think we have one more to go. Add difficulty table. We have one more to go. Oh no, that one broke. So that's the one we've been writing right now. What does this mean? Syntax, missing parentheses after argument list. It's not giving me very good hint at where I made my mistake. But it's something to do with what? Web save module. Is that really the best you can do in terms of error messages for me right now? Okay, okay, actually says this line 16. Oh, okay, I have like syntax highlighting even. So I must have something that's not balanced. Oh, I know. Here we have a parenthesis that needs to be closed here. Oh, typo. Another typo, and that's doing really great. Yay, finally. Cool. Difficulty ID has now been added, and the old difficulty string field is no longer inside. And this ID, it's not nullable. Yeah, cool. It shouldn't be auto-incrementing because it's referencing, it could be any kind of difficulty that's assigned. All right, I think now we just need to run the down migration to see if that works. It did not. Let's see if it's what I suspected. All the table modules drop difficulty. ID cannot drop column needed in a foreign key constraint. Yes, that was what I expected. So we need to actually explicitly we need to drop the foreign key. I think it's just called drop foreign. Let's check the docs. Drop foreign. It's called drop foreign, and I think it's just like drop foreign and then the name of the. Oops. Drop foreign. What's doing for me? Difficulty ID. Complaining. Duplicate column name difficulty. Huh. So it cannot create this guy because we already have a column called difficulty, but that column should be deleted, right? Yeah, now we have difficulty and difficulty ID. Maybe part of the migration did run and part of it did not. So this is again, make sure when you're doing this stuff in between your failed runs, make sure to wipe everything. And if you did not wipe everything, then it's important that you, before you push anything, you make sure to wipe everything and then do migrate latest. And then you just step down, use the migrate down a few times so you make sure you can go through your reverse migration. So you can see actually now we did run our reverse down migration. So it was just because our database was in an inconsistent state. that it could not run before. So now I change it back to difficulty. That's a string. And if I run up, it's changed into a foreign key. And just for good measure, we can do run again or down again, and then we can do. So we can also go the second step back. Then we can do latest. Now we are at the most recent current state. Cool. So now you should know how to do migrations. And if you run into problems, you know how to find the documentation on the knexjs website here. And of course, you should go through the README file here. The last thing I want to talk about is making seed files. So especially when you're doing all of these tests and you go and you delete your database, it gets really annoying if every time you are also deleting your test data. So you might have manually been typing some test data into your application, and that's frustrating losing that. But how about rather than manually typing test data into your application, you could just put some test data into a file, and that test data gets automatically put out every time you make like a testing environment. Then you have some content in there so you can see that everything works. I think that's a great idea. So let's look into how we can do that. So we do that with using seed files. And currently we actually have one seed file here. It's called modules.js. And that will create data here, JavaScript 2, JavaScript 1, and so forth. This stuff is old, so it don't have our difficulty, our changes to the schema right now, right? So I think the seed will actually run because we did not, or did we set the, we did set this guy here to be not nullable. So I think if I try to run the seed right now, it will fail because so this is a command to run the seeds, unless I'm remembering wrong. Let's just go to our docs and make sure. Seed run should be fine. Yeah, so it cannot currently seed. Field difficulty ID doesn't have a default value. Okay, cool. So the reason is that this seed that we have here does not actually get any difficulties assigned. So we can do that. We can just add difficulty ID, and then we can do 1. So that's maybe easy. Difficulty ID 2, so that's like intermediate, medium, whatever we call it. Yeah, it's complaining that it's not in camel case, but this is actually database fields. They should be cased like this unless we decide to change something. Yeah, I mean, this video is, when it's recording, we generally name our database stuff like this, but maybe in the future we'll change it. So make sure to check the reference, like the coding style that we have for your project. Now the seed should be able to run. Actually, I'm not sure it will be. No, I don't think it will run. Let's see why. It does not run. So now it's complaining. Cannot add or update a child row. A foreign key constraint fails. The reason the foreign key constraint fails is because we do not have anything in the difficulty table. So we don't have anything with the ID 1 or the ID 2. So these two are, I think it should be numbers rather than strings. But it will still fail. We need to create a seed file. So let's figure out how to create a seed file. Because we need to seed the difficulty table, not just the modules table. We need to seed both tables. So we have this option here: knex seed make seed name. Knex seed make, and then the name of the seed. I want to call it. So I want to make sure that this seed is being run before the modules one, because we need to have the difficulties in the database before we start putting stuff in the modules. Difficulty difficulties. So running this script here will create a file for us, difficulties. And it just gives us like this empty template. We have to remember to update the table name ourselves. I can see we also need to update it up here. Yeah, maybe just to tell you what happens here. The first thing seeding will do is it will delete everything you have in that table. So seeding is actually destructive. It's not it's only supposed to be run on development environments where you can always delete the data, not on production. So you replace the table here with the table that you want to seed. Difficulty. And then the first thing that happens, it will take any existing content in that table and delete it. It's kind of the same I'm doing whenever I'm deleting my database, right? So delete all of the content, and then afterwards it will insert the content from this file here. So let's just give them IDs, label, easy, description, these are the most easy modules that anyone can do. So that's the description. Let me just make sure for reference that this is actually how we structured our difficulty table. So we are going for structure. Yeah, label, varchar, description, varchar. These have defaults. This one has auto increment, but we are going to assign it ourselves. We want to control that the IDs are what we expect them to be, because we're using that to reference whether it's hard, medium, or easy. So we're going to fill those out. So the ID is there, the label, and the description. So number 2 is going to be medium. These modules are harder than the easy ones. Hope you can do it. Finally, we have, let's copy that again. Finally, we have the hard ones with ID 3. These are the hardest modules. Only few students can finish. Can you? Cool. So we have the ID, the label, and the description, and I think otherwise I think the format should be right. We have the table set here. So let's try to run the seed. Seed run. Yes, it ran. Cool. This is exciting. So if we go to modules now and we go to data, you can see we have JavaScript 2 and we have JavaScript 1. We have difficulty IDs. And if we go to difficulty, we have easy, medium, we have hard. And actually I just want to make one quick change here. So you can see I put the 0, 1 difficulties. That was just because everything is executed in alphabetic order. I just want to make sure that they maintain that order. So I'm just going to put 2 modules here. So in contrast with migrations, that you can actually go and edit your seed files at any point in time. The seed files are only designed to be working with the latest version of your product. And they always work by deleting the data that's in the application beforehand, so you don't have to think about modifying old seeds or anything like that. They're just static. You run the seed and you just put them into the database at any point in time. So you can go and edit existing seed files, whereas the migrations here, I told you never to edit migrations that you have committed to. So never edit migrations that have already been shared with other people on the project. The seed files you can edit at any given point in time. But you need to make sure that they keep up with the migrations, because the seed files will break if someone make migrations and they don't update the seed files as well. So that's something to keep in mind when you make migrations, is you probably have to test that seeding works, and you might have to go and update your seed files whenever you change something. So yeah, I think the last thing I just want to show you is I just want to demonstrate that if I delete my entire database, imagine I come and I check out this project for the very first time. I have nothing in the project right now. I just want to get up and running really fast. So what I will do is I will be running npm run db setup. Boom, it ran my migrations, it ran my seed files. And if I go to my database, I have all the data that we just saw a minute ago. So all of that data is recreated from the scripts that we have been building with migrations and with seeds. So migrations is what we take care of to control the schema of the database. And remember, again, you cannot edit old migrations. You always have to have a down migration for every of your up migrations, and you need to test that I will actually take you back to the state that you had before. And the seed files are static, so you can always go back and edit those, but the seed files you should always make sure that the seed files match the latest version of the database. So whenever you run knex migrate latest, you should expect that to be the schema of the database that your migration should work with. So going back to the diagram that we had here. So now we have taught Diana to use migrations. So what happens now? I don't know. Let's throw something like this in here. Migration. So now, rather than making her changes directly on the database, Diana will make migrations. And those migrations will be put into Git. And those migrations will then be applied automatically to the database. And that's really, really cool, because if we have like a setup where we replicate this, but without the people, because this is an automatic setup. So if we have like a production environment, everything has to like run automatically, then all of the migrations will go to the database automatically. Diana no longer needs to connect to the production server and run her changes manually. With, of course, the risk that you might make a mistake, and she's actually making a mistake on production. That's not very nice. And you can replicate this as many times as you want if you have many servers. It's super easy to work with. But of course, it takes a little bit of work to make those migrations. But I promise you, they might be a little frustrating to write sometimes, but it's so much more frustrating to be in a software team where nobody's writing migrations. You'll be spending so much time trying to debug database issues. So this is a really important topic, and I hope you stayed with me for this whole time, and I hope you feel comfortable going out and writing some migrations and some seeds now. I think that's something that will help you tremendously in the future. So thanks for now. Take care.